if x is equal to u squared minus v squared, y is equal to 2uv, and z is equal to u squared plus v squared, and if x is equal to 11, what is the value of z? So this is a really hard question, I think, because I think this it sort of leads you on. It makes you think that it's going to be testing you on difference of squares and quadratics, but it's really not. And so what this question does is it backs you into a corner, and then you got to figure out how to get out of it. And so you sort of need to use your brain to do this. And I can't always rely on my brain for questions that have an unrecognizable format. So if I got stuck on this question, I might have to move on. But if you were to come across this question, it'd probably be worth a decent amount of points. So let's go through it. What do we notice here? Everything is in terms of u and v. So the key to finding anything else is lies through finding out stuff about u and v. It looks like. So statement 1 says y is equal to 60. So if y is equal to 2uv and y is equal to 60, what does that mean about u and v? So u times v must be equal to 30. Now there's I don't see another uv anywhere, so we can't plug this in or anything. You might say, okay, there's nothing else I can do, and this is insufficient. But let's think about this for a second. So the other thing we know is x is equal to 11. So 11 is so u squared minus v squared is equal to 11. Now here, so like if you're thinking, oh, I can maybe add these two equations and get a quadratic, but not really, because it's not going to be equal to 0. So that's wouldn't be helpful. And then if you try doing factoring this guy here as a difference of squares, I don't think that would be helpful either. Really, what you got to do is just sort of think about this. We know that both of these equations here are telling me something about u and v, and so if u times v has to be two numbers that multiply to 30, and the difference of their squares is equal to 11. Well, there can only be, those are such unique properties, there can really be only one pair of numbers that does that. Now, in other words, even if I don't know what those two numbers are, there's going to be a unique pair that that gives me those two things, that multiply to 30, and then when you subtract their squares, they equal to 11. So if I were to think, for example, if I was just to start writing out what are the factors of 30, so you can have 1 times 30, you can have 2 times 15, 3 times 10, 5 times 6, and after this is just going to go in reverse, so 6 times 5, 10 times 3, 15 times 2, and 30 times 1. So of these, what are the chances of if you subtract their squares, you're going to get something that's equal to 11. So none of these are going to work. So like these are my u's and these are my possible v's, because these are all going to give negative numbers. And so then once we get here, this gives us 11. And so because this is 36 minus 25, there's not going to be another pair, a set of u's and v's that's going to have these two properties. So this is like 100 minus 9, so that's way too big. This is 225 minus 4, and this is 900 minus, so none of these are even close. And even if you start including all the decimal possibilities that u and v could be, none of them are going to fit both of these criteria. And I don't know if there is really a great way to solve this other than to just solve it algebraically. You really just sort of have to think about it. That's what makes this question so tough. But based on this, we can figure out what u and v is. So, u has to be 6 and v has to be 5. And so they're asking for z. So we definitely find z here, because z then would be equal to 36 plus 25. Which is equal to what? 61. So the real point is, if they're asking for z, we really want to find u and v. So this guy actually is sufficient. Statement 2 says u is equal to 6. So what do we know? The one equation that gives us the most information. So we know 11 is equal to 36 minus v squared. And we also know y is equal to 12v now. Does that help at all? So let's see. So can I figure out what v is here? And is that even going to be helpful if I can do so? We know v squared is going to be equal to 25, it looks like. And though based on this, v can either be positive or negative 5, which means u can be positive or negative 6, but actually they tell us u is 6. So now, if we're looking for z here, does this matter that v can be plus or negative 5? No, because when we square it, it's always going to be 25. So we know u is 6. We know v is plus or minus 5. And so we could definitely find u squared plus v squared. So this will also be sufficient. A bit better than the first statement. But both of those, I would say, are pretty tricky and really just you got to think about them a bit. D. Tough question.